Let's continue with division. Here is the first one. X minus 4 divided by 5x minus 20. Everything divided by 13x over 5. Perfect. Remember, we are not allowed to simplify across in a division. This is not allowed. You have to wait till you change it into a product. So, it doesn't matter whether it's a product or a division. I am still allowed to simplify each fraction by itself. 13x over 5 I cannot simplify, so I cannot do anything to it. But what about factoring the denominator? Factor out 5, and then I have x minus 4. I will flip this to 5 over 13x. I only have 2 restrictions to write, and then I can simplify.
It can't be 4
or
0.
Or 0. Very good. It cannot be 4 or 0. Now I'm allowed to simplify. I'll simplify a factor of x minus 4 with a factor of x minus 4. A factor of 5 with a factor of 5. Please write 1 so you don't think that it's 0 at the top. So then what is the simplified form? Of course, assuming that x is never 0 or 4.
1 over 13.
1 over 13x. Assuming these conditions are fulfilled. Otherwise, the whole thing goes away. This is the way we divide. And notice that there is an extra condition or restriction on x. Let me stop here for a second. The moment I flip, I have an extra restriction on x, which I did not have in the division form. But once I flip it, there is a new denominator that I have to take care of. Good? Good. Okay, so let's work on this for a minute. I'm changing it to x because it's easier for me to write. So x squared minus x over x squared minus 1 divided by x plus 1 over x squared plus 2x plus 1. So x squared minus x over x squared minus 1. Everything divided by x plus 1 over x squared plus 2x plus 1. Remember, we can only simplify factors. Don't attempt anything.
Good. Factor everything out.
Good. Don't forget restrictions.
Yes.
Should we wait for another minute?
Yes.
Okay, perfect. Okay, so let's start with the numerator. What do you think we need to do with x squared minus x?
Factor x out.
x. And what is left in parentheses?
X minus 1.
X minus 1. What about the denominator?
That's a factor of squares.
The
So
difference-
X plus 1.
Yes, the difference of squares. Very good.
That's what the difference is. Squares.
Perfect. Divided by. The numerator is x plus 1. What do we do with the denominator?
That's X plus 1, X plus 1.
Meaning x plus 1 squared. Very good. Very good.
Right. Yeah.
We can, at this point, we have to state restrictions.
Which is X cannot be plus or minus 1.
That's it. Very good. Now I can simplify not across, but I can simplify each fraction by itself. I am allowed to do that. So x minus 1 with x minus 1. And x plus 1 with one of those. So therefore, the first fraction is x over x plus 1. The next one I have to flip. It's going to be x plus 1 over 1. No new denominators popped up that I have to state restrictions for. And at this point, I'm done. So the simplified form is x, assuming all conditions work. Is this clear? Very good. I like to look at any questions, please? Any questions? Okay. I like us to look at some of these word problems. 35, 36. Okay, so let's see what they want. In 35, write a simplified rational expression for the area of the figure. Assume that all measures are in inches. Okay. So we are given a rectangular figure. The width is x squared minus 9 over x squared minus 81. And the length is x plus 9 over x squared minus 3x. And they want us to express the area, which we know is length times width. So basically, this is an exercise in multiplying two rational expressions. Of course, we have to state restrictions after we simplify, but first let's write the multiplication. Okay, so then the area equals x plus 9 over x squared minus 3x multiplied by x squared minus 9 over x squared minus 81. This is what we have, and we need to multiply. We never multiply before we simplify, and we completely factor, and then simplify. Good. So x plus 9 is x plus 9. What do we do with the denominator? Factor out x, so we have x minus 3.
Oh,
Now, the numerator of x squared minus 9, we have to completely factor that.
X plus 9, X minus 9.
You mean 3.
Yes, that's what,
Perfect.
yes.
Now the denominator,
That's what I wrote
Good.
down here.
x minus 9 and x plus 9. We cannot touch anything before we state restrictions. No denominator can be 0. No factor in the denominator can be 0.
It can't be plus or minus 9,
Yes,
3 or 0.
indeed. 0 from here, 3 from here, 9 from here, negative 9 from here. These are the restrictions on x. Restrictions on the variable. Restrictions on the variable. Now I am allowed to, after I stated the restrictions on the raw expression, I am allowed to simplify. I will simplify from the denominator x minus 3 with an x minus 3 from the numerator. I will simplify an x plus 9 from the numerator with an x plus 9 from the denominator. And now I will write the final simplified form, assuming all conditions are fulfilled. And the simplified form is
X plus 3 over X minus 9.
we do not, very
or
good.
X-
We do not multiply factors in the denominator. I never said that, sorry. Let me say it now. I'm going to put it in writing. Do not expand denominators. We want all denominators to be fully factored. Is it a mistake? No. If you say the denominator is x squared minus 9x, it's not a mistake at all. But we want all denominators to be fully factored. We keep all denominators fully factored. We keep all denominators fully factored. Good. Okay, let's look at the last one here, 36. Write a simplified rational expression for the area of the figure. Assume that all measures are in inches. Fine. So in this case, we have a triangle, and we are given the base and the height. And the base is 48x over x squared minus 7x plus 6. And the height is x minus 1 over 4. So they're asking us to write the area. So the area of this triangle is base times height divided by 2. It is wise to put 1/2 in front like this. And then put the base, which is this, 48x over x squared minus 7x plus 6, and multiply by the height, which is x minus 1 divided by 4. Good. So notice what I'm going to do first. I'm going to simplify by 2, but I can also simplify by 4. So we have 6x in the numerator. We're going to factor x squared minus 7x plus 6 and multiply it by x minus 1 over 1. Clearing factors that are numbers is always wise to get them out of the way immediately. So first I simplified by 2 and I got 24, and then I simplified by 4. How do we factor x squared minus 7x plus 6?
Minus 6, minus 1.
Yes, x minus 6, x minus 1. I need 2 restrictions, and only then we can simplify. So we have 1 and 6, very good. And now I'm allowed to simplify. I will simplify by x minus 1. So then the numerator is 6x, and the denominator is x minus 6. If you try to simplify the 6, there will be an absolute terrible mistake. So the simplified form of the area is 6x over x minus 6, but only under the condition that x is never 1 and x is never 6. Any questions on evaluating, simplifying, multiplying, and dividing rational expressions? Any questions why we state restrictions? Any questions on how to determine when is a rational expression undefined? Okay. Moving on to the next step. And the next step should not be this. I disagree with the order of the class. The next step should be adding and subtracting rational expressions, not a totally different topic that has nothing to do with anything. Okay? So graphing inequalities on a real number line, using interval notation, using inequality notation and graphing inequalities, linear inequalities, using properties of inequalities, solving linear inequalities, and so on and so forth. Model has nothing to do with what we are trying to do here. So I disagree with the steps. Okay, so this will be our next solving inequalities. Then graphing equations, introduction to functions, square roots. I guess the coordinator of the class moved the adding and subtracting to the next class. I disagree, but it is what it is. Good. So let's talk about inequalities. Okay, so this is the end of the second application of factoring. The first one was solving equations. The second one was to simplify rational expressions, simplify them when we multiply them, and simplify them when we divide them. And that is the end of it. Good. Next topic. So this is 7.2, inequalities. And interval notation. Okay, so inequalities, let me see the time here. Let me